Thank you for inviting me to speak on this topic. I'm going to be talking for the next 30 minutes on some of our projects and experience in ESG in airports. My name is Tim Aldeburgh and I work for WSP in Singapore. I will cover this agenda, just give you a little bit of introduction to WSP, the ESG landscape, some of which you may already be familiar with, and some project case studies. And there will be a 10-minute question and answer period immediately after my talk. So just to introduce WSP, we are a global company, about 68,000 employees across the world. We have activities across all the built environment, transport and infrastructure, properties and buildings, environment, industry, energy, mining. So we do a lot of work in the earth sciences and environmental consulting arena, and we've won a number of awards. And in the region in Asia, we have about 3,400 employees, 13 offices. Our headquarters is in Hong Kong, and we have quite a strong office in Taipei as well. And our key net zero carbon service areas, you can see on the slide, I'll read them out so you can see them in Chinese: circular economy, sustainable resources and waste management, carbon management and strategy, climate risk and resilience, corporate sustainability strategy, ESG reporting and environmental management, and industrial process sustainability, decarbonisation and permitting. We have a number of manufacturing clients whose facilities are in China, and we do a lot of carbon baseline for those manufacturers. They're often selling their products internationally, so they need to be aware of legislation in the markets that they wish to sell their products. So we do a lot of support in helping them with that. As a company ourselves, we are very robust in reporting our own ESG metrics and our sustainability program. We're rated A by CDP, which is one of only 2 firms in our industry. We have submitted science-based targets at a 1.5 degree trajectory and had those approved by the SBTi. And as we're listed on the Toronto Stock Exchange, we also have to report our TCFD, which is a financial reporting metric. And more recently, we've been voted by Verdantix, who are a global assessment company, that our climate change consulting services are right up there with the top companies. So we're very pleased about that. And we also are the founding. We developed the carbon accreditation program with the ACI, and we have been administering it since the beginning, and we continue to do so on behalf of the ACI. So there are over 542 airports that have joined this ACA scheme and are at various levels, as you can see in the coloured bars of progress. And we continue to support airports across the world in their efforts to decarbonise and transform and transition. And we also have a lot of thought leadership. So we publish a lot of papers on many things, but these ones are particularly on the airport and aviation sector, but also about decarbonisation of the built environment. So there's some properties and buildings projects that we have here. There's a lot more retrofit nowadays. I think ANA works, which in order to conserve the embodied carbon in the existing structures, it's getting more and more difficult to demolish full structures without first evidencing that you've gone through the process of identifying whether or not they can be retrofitted, and a lot of the embodied carbon retained or invested for the future. So just on the ESG landscape, again, I don't want to teach you to suck eggs, but the main areas that we have here are listed. When we talk about ESG, there's a big social and governance aspect to it as much as there is environment. I think the conference here is focused particularly on environment. This slide, if it helps in Chinese, will help you to understand what some of those topics are. And we find that generally speaking, we start with greenhouse gas accounting. That's one of the main entry points for ESG. Companies obviously want to ensure they have good social and governance aspects as well, but certainly at the moment, regulation, policy, renewables and energy, resilience, and decarbonisation are the key areas that clients are focused on, particularly for airports. So again, I'm sure you understand all this already, but GHG emissions, greenhouse gases, we tend to account for them in terms of a CO2 equivalent. So even though there are other pollutants and other gases being emitted into the atmosphere, we bring it all down to an equation that is a CO2 equivalent per ton of CO2. So we can see that. And then we have, if we follow the GHG protocol, which we do in most of our assessments, we have scope 1, scope 2, and scope 3, which I think, again, you're probably familiar with. Scope 1 being the emissions directly from the operations of an organization. Scope 2 being the energy that is utilized by that organization, and then scope 3 being the supply chain. And for different types of organization, the supply chain can be quite complex or relatively straightforward. If we're talking about a consultancy firm, we're probably dealing only with purchasing of things like paper and other materials that we use. But for manufacturing, there can be a very complex chain, which we help clients to unravel and understand and to account for in terms of its carbon footprint. And then what are the drivers? So in different parts of the world at the moment, there are different drivers, but these are the top headline drivers that are pushing companies and asset owners to address their carbon footprint. Regulation is a very key one, and in Europe now there are lots of fines and restrictions on activities if you don't meet regulatory requirements. Customer expectations, if we're talking about airports, particularly customers are using airports, they want to know that they're optimizing the reduction of carbon emissions. Investor pressure, again, investors are very keen to invest in green projects. They're looking for those very keenly. Action-oriented management, so the management of organizations can also drive the change. Climate risk, airports are at risk, particularly of climate. Many of them are coastal-based airports. Others are in cities where flood risk is often a key metric, and high wind conditions. Decarbonisation targets, target setting is key, obviously, if you're going to drive it down. So that's a real driver of calculating a baseline. And then consumer awareness and the desire to reduce emissions overall. So these are the main drivers we see in our region. It's the driving speed is quite different from some other regions, and it is quite a regional thing, but we're looking to push and drive this forward so that the world moves at one speed on this. And then when we look at accounting, ESG was originally set up to look at the risk for investors in assets, so to measure the risks across the different environmental, social, and governance metrics to make sure that they were satisfied with the risk levels, or that risk was being managed adequately by organizations. Nowadays, a lot of the GHG emissions accounting is specifically focused on the environment, and the Greenhouse Gas Protocol, or ISO 16064, is the two main accounting baselines that we use. And there are science-based targets, which a number of companies have engaged with and submitted. And then there is financial accounting, and we're not talking about financial accounting here, but that there is an overlap with TCFD where listed companies or companies with significant investors or government investors have to report on an annual basis to show the resilience of their finances in the face of the ESG and environmental concerns. So again, as we're talking about drivers change, particularly in aviation, we're looking at airports around the world where sea level rises will be significant in terms of their impact. We've already seen that in our region. Kansai Airport on the bottom right-hand side was flooded last year. And there are a number of other airports around our region. Over 100 airports by 2100 will be at risk. So when we're looking at drivers of change in aviation, airport upgrades and refurbishment programs provide an opportunity to reduce carbon and to focus on the carbon footprint and the sustainability and the operational efficiency. Climate resilience, as I've just mentioned, flood defenses, pandemic response, which is part of the social and governance response to that airports have, is quite keen. And some of the new designs we're looking at are modular. They're looking at the spaces within the airports, how they can be modularized. So if a new pandemic came, parts of the airport could continue potentially to operate whilst others might be closed off as necessary. And supply chain diversification, we're seeing that around the region. A lot of the aviation sector relies on quite a spread of smaller companies providing elements, and we'll see that in one of the case studies later. And digitization for operational efficiency, that's a big thing in airports at the moment. Customers expecting more digitization, more sort of apps that can help them navigate airports and airport facilities. And also the airports themselves, they want more data from their operations so that they can optimize operations. And then airspace management. It makes a huge difference the way in which airspace is managed as to how much fuel an airline might use. And so it's really important that airspace management is optimized. And there's also the new eVTOL aircraft that are coming in and the unmanned aircraft. And there needs to be strategies put in place to manage those as well. So, and then supply chain, I've mentioned already, supply chain accountability, finding out where the materials are coming from that are going into airports or any built assets really. There's a lot of growing calls from investors, from governments and regulators, communities, corporations to drive the desire to have a greater visibility of the supply chain right down to where the product is coming from and to estimate a carbon footprint. And again, we'll see what that means for materials when we talk about EPDs a bit later on. So again, going to an aviation context, I wanted to share a particular case study that we conducted in the Middle East for a new airport and the impact that it had on that airport in terms of its design. We looked at all the potential impacts internally and externally on environmental and sustainability programs to ensure that the airport was well armed really with information. So we looked internally at the aircraft technologies that were available currently and would come in the future so that the airport would have in mind how they might cater for them in the future. Airspace management, as I've just mentioned previously, airline operations. So again, airlines are a subsidiary. They're not always controlled by the airports, but they operate out of airports and they themselves have their own carbon footprints to deal with and their own sustainability issues. And airport sustainability as a whole, which is one of the key focuses of new airport developments. And then externally, there's obviously regulation and policies, geopolitical context that we looked at in the region of the Middle East for the airport and its competition. The impact of the pandemic, again, this work was done in 2021, so it was quite relevant at that time. And customer perceptions and considerations. So a little bit more detail on each of these as I go through. Hopefully the translations are coming through clearly. Aircraft technology. So we looked at emerging eco-efficient aircraft types. There are a lot out there at the moment. There's lots of different R&Ds going on, different opportunities to decarbonize aviation travel, particularly with aircraft. There are technologies to retrofit existing aircraft that actually reduce the amount of fuel they use quite considerably. So there are fuel efficiency gains from enhanced aerodynamics. And there are new methods to power aircraft. The three particular ones that are being focused on, I think, by most are electric, hydrogen, and sustainable aviation fuels, which are, you may be familiar with them. They are fuels that have basically had a past life, so their carbon footprint is considered to be less than it would be if it was new fuel. They still put new CO2 into the upper atmosphere, but they are considered more sustainable than current airline fuel. And airline operations, so again, managing noise with aircraft is one of the big areas that we get involved with. We have an acoustics team across the world that deal with aircraft noise, and we've just presented 2 weeks ago in Guangzhou aircraft noise assessment work that we've done globally. Aircraft emissions and local air quality, eco-efficient ground handling. So again, all the ground handling equipment, more and more it's becoming electric, but still quite a lot of diesel operated. And more they're looking at autonomy in that area as well, so that they can operate more efficiently on the air side of the airport. And then carbon offset schemes. So there are a number of schemes around. Carbon offset schemes are under scrutiny at the moment because the environment is in crisis, and it's very difficult to say that we can definitely use a forest here or a forest there for carbon offsets when those forests may indeed burn down. So yeah, we need to be careful with offsets. We need to make sure they're robust. And airspace management. So local and regional airspace analysis was conducted in the Middle East to understand how the new airport would interact with existing flight paths and how it could optimize its navigation routes. And also looking at different criteria of maturity level in terms of timeframes and dependencies. And then airport sustainability, this is the one that will be most familiar to this audience perhaps, is looking at sustainable solutions for energy sources. So renewable energy on site or bringing it to the site if the grid is green. Bioclimatic architectural concepts, so things like greening with plants, particularly in the terminal buildings and the facades of buildings, and also around the airport as well, provided it doesn't encourage bird life to proliferate around the airport. So material and waste management. Again, airports do produce quite a lot of waste, so it's important to manage that. Airlines particularly as well, a lot of single-use plastic, which is slowly, but quite slowly being designed out of most operations, but still is there in quite quantity. And airfield operations, airport resilience, again, I've mentioned before. So, you know, is the airport, if it's in an area that isn't resilient, how can we make it more resilient through design? How can we look at resilience response in situations where we can't manage it through design? Water management, water again becoming much more of an issue. The water resilience in many countries now is a crisis level. We need to look at, and we are looking at a number of facilities that are where the water stays on site. They don't use any more water than they already have. They have an existing amount and they recycle it, and they only add to it as and when they need to. So that can be a real challenge as well, to manage water, to have water treatment facilities, water purification on site. Site sustainability is an overall topic as well, to ensure that airports in particular, they usually have quite large perimeters and quite large areas. So how can we make them more sustainable? And then wellness and thermal comfort. Wellness is coming in as quite a strong metric really within ESG, and particularly for buildings that are frequented by the general public. Accessibility, quality of air, quality of the environment within the airport is very important. And office buildings as well are looking at a lot of wellness criteria these days. And then each of these areas was assessed against chosen KPIs: eco-efficiency, technical feasibility, the relative capital cost, CapEx, and the operational costs as well, the implications on OpEx. Would the OpEx be more efficient? And then we looked at the airport carbon accreditation scheme as well in relation to this new airport, and the analysis of recommended environmental and certification frameworks. So what frameworks would the client want to address and adopt? Each has a different capital cost, each has a green penalty, if you like, and asset owners want to understand whether that is a viable proposition. So then we looked also at the, as I said, the external influences, sustainability regulations. I won't go through these in detail, but ICAO and IATA have their own published standards, which many airlines and airports will want to meet. And then the regional political context, how competitor airports might affect the airport in terms of its efficiency. If you don't get really full efficiency out of your runway use in terms of airspace, then that can be quite a significant impact on the sustainability goals. If you measure the metrics of it's a bit like occupancy in a building. If you don't have full occupancy, then your sustainability levels will decrease because your operational efficiency is supporting less than it could actually or is actually designed for. And then benchmarking competitor airlines. So airports have to understand which airlines are going to want to come to their airport and how they can manage that and how they can bring in the big names and generate revenue. So it's important to look at these as risks and opportunities. And we looked at the ground service equipment technologies, synergies with partnering with other airports, which is also quite an important part of aviation these days. And then impact of pandemic, I won't go through that in detail, and customer perceptions and considerations. So more and more in Europe, there's what we call flight shaming, which is people are encouraged to take trains when they can and not to fly and not to go on long haul holidays, and actually change the way they live their life based on the environmental impact that it might have. And that's quite a challenge for us to see how willing we are to change our lifestyles for the climate. And then so ultimately we came up with a sustainability roadmap for that airport, plotted right through to 2050, different activities happening along the route as and when some of the technologies were available or perceived to be available. And we gave them some key steps in their sustainability program. So that was quite a piece of work for an airport, and they wanted to do that all upfront prior to even commencing the design of the airport, so they could capture the information as early as possible. And then when we're looking very specifically at the airport context, we have a checklist for the planning and delivery opportunities that we look at within the airport, which is on the right-hand side here. And then we also apply what we call future ready to all our projects, and we look at the mega trends: climate, resources, technology, society. We're not only looking at the present time, we're not even just looking at the projected whole of life of the asset. We're looking beyond that still to see whether that whole of life can be extended. What are the current best opportunities for technology, which is obviously becoming obsolete in very short timeframes today? What are the resource issues going to be like in 30, 40 years time? And the climate, how is this asset going to respond to the climate changes that are going to happen in its lifetime? And also society, is that going to change the way in which the asset is used and perceived? So we try and get all those in view at the beginning. We'll conduct techno-economic evaluations. So that means basically what technologies are available, how much they're going to cost, when will they be available, are they really going to come to commercial fruition and be fully available? We looked at carbon capture and storage recently, and again, how available is that going to be to the wider market in the near term? Probably not, but probably beyond 2040, there may be some real opportunity for it. So so those are the things we look at. And then again, you're probably familiar with PAS 2080, maybe not. It's a carbon management and infrastructure standard. And it very clearly sets out that the earlier you get involved in a project, if you can get involved at strategy and brief and concept design, then you will be able to influence the emissions, particularly the embodied carbon, but also the operational carbon as well, much more for much less cost. And the longer you leave it in the life cycle of your procurement, the harder it is to green the asset and the more expensive it gets. So this is a good thing to remember when we're looking at projects. And then for those of you who perhaps don't have a full comprehension of what embodied and operational carbon is, this is quite a good diagram produced by the London Energy Transformation Initiative in the UK. And it shows clearly the operational carbon in yellow and the embodied carbon in red. And the reason we want to get embodied carbon down is when you just have practical completion and turn on the lights, you've already got a massive footprint of embodied carbon within that building. And we measure it in energy use intensity, which is kilowatt hours divided by the square meterage of that building or that asset or that terminal, if it's an airport. And then there will be interventions during its lifetime. So some major replacements of maybe HVAC equipment or lifts and escalators, things like that, and then an end-of-life residual embodied carbon. And it's important we try and get this down because going forward, there will be legislation that requires buildings to have a maximum level of energy use intensity. In the UK now, you cannot get planning permission for a new building unless you evidence the level of energy use intensity and the fact that you've worked on it already to make it as optimal as possible. So your planning application will be dependent on your sustainability efforts even prior to commissioning the detailed design. And then as we get more operationally efficient, you can see that the embodied energy as a metric of energy, embodied carbon, becomes almost the whole pie by the 2050s, because operationally we're going to be very efficient. There's been a lot of green building efforts, mostly on operational, because that saves the client money as well as the environment. But embodied has not had as much attention paid to it, and it is becoming now more important. And what we do in most of our projects is we will take the standard design and we'll look at every element of the design. So say this was a terminal building or even an office, commercial building, residential. We'll look at every element: foundations, floor slabs, walls, beams, and we'll look at options that might reduce the embodied carbon. And we'll come up with the alternatives, and we'll look at those alternatives both in terms of reduction in environmental impact, but also cost, because there is always going to be a cost premium to pay currently still for greener materials and greener design potentially. So we want the client to be informed. We want them to understand this. So that's quite clear for us. And then also carbon pricing. You may be aware that a number of organizations have an internal cost of carbon. So they apply as a matter of choice a cost to the tonnage of carbon dioxide equivalent that's being produced by their projects. And this is in anticipation of a carbon tax in the future, where every ton of embodied carbon will be taxed, potentially. In some markets, it's already getting to that level of legislation. And in the UK, it's probably the most stringent. The government uses a very high metric. Individual companies probably somewhere around the 70 to 100 pound mark. We have a client here in Singapore who's building a new factory facility, and they have applied their internal cost of carbon, and it helps them to think about reducing carbon in their designs, because there is a financial impact, and it's usually only when it gets to a financial impact that management start to respond. And then what a lot of companies are doing is they put that equivalent internal cost of carbon into a transition fund. So a new build project will have, say, 100 tons of carbon. They'll put their cost per ton of carbon times 100 into a transition fund, and they will use that money to green existing assets. So they'll use that as a fund to green assets that are not actually being refurbished, etc., but they can then use that money and refurbish them. So that's a way of greening an entire portfolio if you have more than one asset. And airports can do that as well. They can do that for upgrades of existing terminals when they build new assets and new facilities around the airport. So that's quite important. And then EPDs, I was going to touch on this. So environmental product declaration forms, more and more materials are having EPDs linked to them, so that they're basically a certificate that tells the purchaser how much global warming potential that product has, that material. And because it's material specific and manufacturing specific, we can compare one supplier of concrete with another, and I'll show you that in a moment, and we can look at the difference, and there is a considerable difference. We can use averages, but when we have the actual factual values, it can make a big difference to our calculations. So EPDs are becoming more and more prevalent. We are looking at tenders now where contractors have part of their scoring, about 20% of their scoring will be a sustainability metric, and it will be based on, number one, how much have they thought about the construction process in terms of greening it, in terms of precasting, in terms of off-site, in terms of reducing the number of vehicular trips to and from the site, but also how much materials are going to be covered by EPDs, what percentage of the materials for the entire project will have product declaration forms that will tell the owner of the asset the carbon footprint of those materials. And that is now becoming a measure. And one of the clients here selected the contractor purely on that metric. There were one particular contractor was way ahead of the others in terms of the sustainability metric, and they won the project. And this is what an EPD looks like. It gives you a global warming potential, which is often what we're looking at. This is a US-centric one, so it's in cubic yards and pounds per CO2 equivalent. But here it's 164 kilograms. And then when we look at suppliers of concrete, for instance, this again in the USA, different suppliers have quite different footprints for different strengths of concrete. And you can see that the actual embodied carbon in each of those products is quite different. It's quite a range. And if you want to really be specific, you can state in your specification that my concrete must have an energy use intensity of less than 300 kilograms of CO2 equivalent per meter cubed. And that can be a challenge because in the local markets that might not be available. So you obviously got to be sure that you can provide it within your market if you're going to specify it. But we can drive that down below 500 for steel, which is important, and below 300 and 250 maybe for concrete. And then again here, if you look at a steel frame versus a concrete frame, if you use average data, you might argue that your concrete frame has more embodied carbon than steel. But if you use manufacturer specific data, you can see that product A and product B actually are less than terms of the embodied carbon. So it's very important that we get as much data as we can, and it's becoming available, but it's not fully available across the market, but it will come, and it will come fast. And WSP, in light of this, we've made a commitment to halving our carbon emissions in our designs and advice by 2030, and this is in certain markets where we know the markets can sustain this, and we have spent quite a lot of time baselining our 2020 projects to understand exactly what the carbon footprint is of those projects, so that we can understand where we need to be in 2030. And it's quite challenging to reduce the amount of carbon in the designs by 50%. That's quite a challenge. So just some more case studies before we finish. Future ready case study for airport energy net zero solutions. We looked at this for a European airport operator. They wanted to look across their portfolio and understand how they could reduce their energy use and make it as green as possible and meet the European Union net zero 2050 targets. They looked at 2036 to fully transition from a 2019 baseline. So they were really looking hard to look at the energy resources. Where could they get green energy from? What innovative technologies could actually drive renewable energy resources better and also make them more efficient operationally? And so we looked, I think the three key ones that came out were on-site solar. Obviously for airports, we have to be mindful of the glare that comes off solar panels and PV panels. We have to position them such they won't affect the pilots. And then battery energy storage systems so that they could capture the peak and off-peak periods and better utilize grid energy, but also maybe store some solar if it's coming in at a rate that they're not using it, they can actually back it up and store it. And also geothermal. So we know of a number of clients, one in Europe at Orly Airport in France, where they've got two 1.8 kilometer deep geothermal wells, and that energy source through the heat differential is enough to power 70% of their terminal buildings' energy requirements. So it's definitely worth looking at geothermal as a future opportunity, particularly at airports that have big footprints. They've got plenty of land on which to drop wells and put the energy capture housing and storage facilities. So it may be more difficult for commercial property developers, but we have seen some, particularly in the City of London. We did a project where they used the foundation piles with geothermal, but the temperature differential for the depth of pile that we were doing was not sufficient to generate more than about 10% of the energy requirements of the building. So, but it was definitely a useful project, and I think going forward, even 10% is a saving. So we're going to be looking at every possible opportunity for saving in the future. So here, ultimately, we came up with a report which gave advice to the client on what the best solutions were in terms of CapEx and OpEx and return in terms of carbon-free energy. So that was an interesting project. And then another project we've done in Canada was looking at using concrete where CO2 that had been captured from industrial processes was folded into the mix. So it's called Carbon Cure. It's available in Singapore, in Vietnam. As I said earlier, we're pushing it into Hong Kong. China, again, could adopt this, and I'm sure that there's opportunity for them to capture a lot of carbon from industry and use it in the mix here. And airports use an enormous amount of concrete. The runways, taxiways, and aprons tend to be almost a meter deep in some cases, sometimes less if the design is optimized. But in terms of the volumes of concrete, it's enormous, and that's before you even consider the buildings and the car parking and elevated roadways, sidewalks, and things. So, so there's a real opportunity here to reduce the embodied carbon in airports as airports rehabilitate runways and resurface taxiways and aprons, etc. And how it works is that the collection of the CO2 from industry or from large emitters such as power stations, steel and concrete manufacturers, oil and gas industry. The gas is then purified, it's liquefied and delivered to site. It's then integrated into the concrete by injection on the bottom right at a certain rate, precise dosaging. I think about 12% by volume of concrete, the CO2 can be injected. And we've also found that the actual concrete strength, whilst not affected in terms of its total strength, it will gain strength very, very quickly at the beginning. So within 3 to 4 days, you'll get your 28-day strength. So that can be a game changer in terms of construction programming. It also can be used in precast elements, which can then be brought to site earlier, be stronger and more robust. And when this CO2 is mixed with the concrete mix, it forms a limestone, which when that asset is then decommissioned and demolished, the CO2 is not released again into the atmosphere. It's actually locked into that limestone matrix. So, so this is something going forward that we know will be of value. We know that it commands a premium of about, in Singapore, about 3% more expensive than standard concrete. And some developers are still not really willing to pay that. So there is a premium to pay. But I think as more and more companies are aware of carbon footprint, that premium won't seem to be so great. Now, finally, this last case study was a supply chain assessment for aircraft, an Airbus A380. Quite a lot of these components are made in our region. 4 million individual parts in this aircraft, produced by 1,500 companies across 30 countries worldwide. And you can imagine the carbon footprint, because they have a process where you have tier 1, 2, and 3 suppliers who assemble various levels and complexities of the components, which are then shipped to be finally assembled at the big Airbus plant, which is in the south of France. So there's quite a lot of toing and froing of components, the component materials, trying to understand where they're coming from. Many of them are quite advanced composites. This was an interesting study to look at and the electrics and all the electronics, etc., to look at how efficient we can make the manufacture of an aircraft and where we can actually find the carbon and reduce it. So that was an interesting study as well. So ESG metrics across aviation tend to be not just buildings; they can be all elements of assets and transportation that go into airports, particularly things like the baggage handling system as well, and APMs, trains, if they have them at the airports. All these things need to be more operationally efficient and electrified, and basically the operational carbon reduced as much as possible, but also the embodied carbon as well. So that's it. Thank you very much for listening.
Hello, Tim.
Hi.
In your slide, can you hear this?
Yes, yeah, much better now, yeah.
About the case study regarding the YYC, that is the decision to airport. They use the clean tech, the carbon tube technology to inject the CO2 into the concrete mix process. And the audience asks regarding the cost effective, and is cost effective to do it to reduce the carbon?
Is it cost effective to do it?
Yes, and how cost and how effective?
Right, so I think I mentioned if you need to reduce the carbon, the embodied carbon, then this is a way to do it, and there are very few other ways to reduce. What you can do is you can use supplementary cementitious materials, so you can replace the cement powder, which is the high carbon content element. It's about 90+% of the carbon footprint of concrete. You can replace it with other materials, but ultimately this is a way of sequestering CO2 from other industry and then capturing it into concrete as well. So it's a double win for the environment, because the CO2 is coming from emissions and it is then being used. So it's a use for carbon that's being captured. And it does have, as I said, it has a cost premium of about 3%, but that's really not a lot if you consider the environment. Basically, this is what we're saying, right? So if you look at the cost per ton, if you did have an internal cost of carbon, and then you compared that with the cost of purchasing a concrete that was green with a 3% premium, you would find you're still saving money on your internal cost of carbon. But you have to agree to have an internal cost of carbon to be able to do that calculation and understand that you're actually saving money equivalent in terms of the carbon footprint of your asset. And so a lot of building construction work now in Singapore particularly is using the low carbon concrete because it's required in the specification. They can't avoid it. It's not optional anymore to use a higher carbon content of concrete. You've got to optimize carbon as much as you can. So it isn't just about whether it's cost effective. There is obviously a cost implication and a loss of carbon, if you like, in the capturing of the carbon, liquefying, purifying, transporting, and injecting. So it's not 100% gain on the carbon that you've captured. You're actually going to burn some in the whole process, but it is still a significant reduction than a situation where you didn't do it. So we are seeing more and more uptake of it. We're seeing more and more understanding that carbon will have a cost implication. So the less carbon, the less cost, and therefore be willing to pay more capex upfront to save. Hope that's an answer.